Python Basics. Hello, this is Ben Finkel, and in this nugget we're going to take a look at a basic introduction to programming with the Python language. Now, Python is really powerful and really complex, so we want to start slowly. We're just going to dip our toes in the water. To start with, we're going to take an introductory look at programming itself, talk about what programming is, what problems we're trying to accomplish, and why we need programming languages like Python. Then we'll look specifically at the Python language and talk about what sets it apart from other potential languages that we could learn and why we want to learn Python itself. Lastly, we'll finish up by executing some real Python code, both in what's called interactive mode, right in the command line of our system, as well as a fully functioning little miniature game that we can play with Python that's been pre-written for us, executed in what's called normal mode. So, let's get started. Let's start with taking a look at some programming basics, talking about what programming is and what it tries to accomplish at a very high level, regardless of what programming language you might be using. And there's a lot of different programming languages out there, a lot of different flavors of coding. C, C#, Java, Python, Lisp, Fortran, COBOL. The list goes on and on. Google it sometime. It's truly amazing how many different languages there are. But all of these different programming languages, all of this code, is attempting to solve the same problem, and that's bridging the gap between you and I as human beings and the computer. Now, a computer is an incredible tool. It's super powerful and it's incredibly flexible. It can be taught to do just about anything that you or I can imagine. And the nerd word for that is logically malleable. That means that the computer, contrary to, say, a machine in a shop somewhere that only does one specific task over and over, can be changed or formed to do any different task. Anything that you can define with a complete formal logical system can be defined inside a computer program, and your computer can accomplish it. It's sort of like the ultimate Swiss Army knife, except it's a Swiss Army knife times, millions and millions and millions, and the list just goes on and on. It can really be programmed to do anything, but programmed is the important word there. A computer is just an empty brick without instructions, without being told ahead of time what it needs to do. And you've seen this in action. If you've used a computer at all before, you've used computer programs. Every time you even do something as simple as move the mouse on the screen, you've used a program because someone had to tell the computer how to draw that little cursor, draw that little arrow, and then tell it what to do when the person moved the mouse across left on your desktop. They had to say, hey, make sure that cursor slides left across the screen. And that program may have been written a long time ago. Who knows who wrote it originally, but at some point someone wrote a program that told your computer how to interpret the motions of the mouse on the desktop. They told your computer what to do when you click that little Windows button in the lower left screen and make that start menu pop up. Told the computer what to do when you double click that video game icon and how to handle the video game that executes on your computer. So all of these things are examples of programs, and they were built by a programming language originally at some basic level. Now, I said earlier that all these different programming languages exist to solve a problem, to bridge a gap between you and I and the computer. And the problem is that the computers are really pretty dumb. Now, I know a lot of people are always saying, oh, computers are so smart and they're getting smarter every day, but that's actually not true. Computers still today are really only good at following instructions. Now, they can do it very quickly and they can perform very complex computational tasks that you and I would never be able to perform, but that doesn't make them smart, it just makes them fast, and that's important. It's a big difference. The natural languages that you and I use, whether it's English or German or Russian or whatever, are full of ambiguities. We use all sorts of things like idiomatic expressions as well as inflection and tone and body language to convey what we mean. We can't convey any of that to a computer. A computer can't make assumptions about what we mean when we tell it to do something. So if I ask you to go fill me up a cup of water, you generally know where to get the cups from, how much water to put into it, whether it should be hot or cold. Computers don't make those assumptions. We need to very explicitly tell a computer every single step that we want it to do when we want it to execute a program. There's no room for ambiguity, and that means we can't use natural languages to create a program. We can't instruct the computer with an English language. So the lowest level language that you typically run into or you typically see is machine code, something called assembly language. And assembly language is still an abstraction of the instructions that a computer exposes to the outside world. And what I mean is this incredibly sort of obscure code that we have here is a one-off set of instructions that the computer knows how to interpret. It's generally moving information around in memory, causing addition and multiplication and those sorts of things to happen. It's very complex. It's also not very legible. You and I looking at this, it's difficult to tell what's going on. I think we recognize that little hello world down there, but the rest of it, total nonsense. At least it is to me. So if you've never programmed in assembly, and most people don't ever have to, none of this makes any sense. It's pretty difficult to translate that into any sort of logical instruction that you and I might use. What we'd prefer to do is we'd prefer to use a language that we're familiar with, say the English language. And that's what these code over here does. This code is called a high-level language. And the high-level languages are closer to the natural human languages that you and I use to communicate with one another, but still somewhat formalized enough that they can be ultimately turned into assembly language. And that's a process called compilation that I liken to baking a cake or cooking. You got to take all these raw ingredients, in our case our raw programs, mix them all together, put them in the oven, and bake them into a final product, a cake, that can get consumed by the computer. Now, because these high-level languages are closer to English than assembly is, they are a little more abstract, and there's a lot more assumptions baked into the process of turning them into machine code, turning them into instructions for the computer. Those assumptions are generally handled inside the compiler. That means as programmers, it's our job to be very explicit and very clear when we're writing a program. We really want to take great care when we write our program to be as well defined in our instructions as possible, because the computer's going to do whatever it is that we tell it to do. It also has implications such as error handling that we need to make sure we handle inside of our programs. The simple fact of the matter is we can't envision every scenario that's going to come up. People are going to use our programs in ways that we never imagined possible. Our computer needs to be able to handle those, if not accurately, at least gracefully, and be able to spit back an error that says what went wrong, why it went wrong, and how we can correct it in the future. That's called error handling. But a lot of that is getting ahead of ourselves. Let's take a look at Python specifically, the language that we are here to learn. So with the multitude of different programming languages that are available out there, what makes Python such a great language to learn, so much fun, and so valuable for us as developers? And the answer is a lot of different things. For one, and maybe a big one, is Python's platform independence. What this means is that you can write Python code once and then ship it out to any platform that you want it to execute on, knowing that it will execute on that platform well. You don't have to refactor your code every time you want to ship it out to a new environment. So this is contrary to something like C, which gets compiled directly into machine code. Python gets only compiled halfway into something they call bytecode. And this looks like a .pyc file. So you're going to write your code in these .py files, and then they're going to produce a .pyc file. And that .pyc file then gets executed on whatever target environment you're shipping it out to. So you can always know that your code is going to run well on any of the environments that Python runs on. And these days Python runs on everything. Python is also a really easy language to learn, and it's very legible. In fact, there's a real focus on Python's legibility. So if you saw on the previous slide, some of those code samples were pretty gruesome looking, particularly the assembly and to a lesser extent the C. Well, Python really has a focus on being humanly legible. You should be able to look at the code and relatively quickly understand what it's doing and how it's working. I got a good sample up here on screen. Now, if you've never programmed before, this may still look like total random nonsense. But if you have even a little bit of experience programming, particularly in something like C or Java, you can look at this and recognize that it's actually pretty easy to read. It's very terse. There's not a lot of extra symbols and semicolons and things like that floating around in the code. And it's relatively understandable. A lot of English language words inside Python. So Python's really easy to learn, really legible. It's a big point in its favor. A lot of people love that about it. And because so many people love that about it, Python also is very popular. Now, this doesn't sound like a big thing at first, but what that means is that there's a broad community support for Python, particularly in something called the Python Package Index. These are all sorts of third-party libraries that people have developed that build onto and expand the functionality of Python itself. So Python is just a programming language that does some very basic things, but when you take a look at the Python Package Index, we'll take a look at that later in this series, there's a whole host of utilities that you can download and instantaneously get up and running inside of your Python program to do, again, just about anything that you can imagine. So for all of those reasons, plus its power and its flexibility and its universal acceptance, really make Python a good language to have in your arsenal of programming languages and a good language to begin learning how to program with. Now, when you're ready to get up and running on Python, and let's do that now in a few minutes here, it's really easy to do. First of all, if you're on Linux or Macintosh, Python is already installed. You don't have to do anything else. It came shipped with your operating system. It's there ready for you to run. So you can just drop into a terminal and start following along with this nugget while we go write some code in a moment. If you're on Windows, it's still not difficult to get up and running. You're simply going to go to python.org and you're going to download the code from there, either 2.7 or 3.1. Now for most of this nugget, we're going to be using 2.7. So you can download and install that version, but if you'd like to get up and running on 3, go right ahead. The differences are going to be really minor, and you're still going to be able to follow along with this entire series on 3. Once you've downloaded that file, it's really easy to install. If you've installed anything on Windows, you simply download it, run the installer, and then you have Python. So if you haven't already, go ahead and pause this nugget, go to python.org and download that installer on your Windows machine, or if you're on Linux or Macintosh, get ready to go because we're going to get started. Now, one more cool thing about Python that I like a whole lot is that it supports both normal and interactive mode. Now, normal mode is what we traditionally think of when we are programming. We're going to build .py files and we are going to turn them into .pyc files and they're going to execute on our system. So you build your entire program and then that entire program gets executed. But for testing purposes and also for scripting purposes, Python offers something called interactive mode. And in interactive mode, we get immediate execution. We're going to be at a Python prompt, or we're going to be able to type something in and immediately see some output from what we keyed in. So that's what we're going to start with now. Let's go ahead and get our terminal up and take a look. Now, for those of you unfamiliar, terminals are a way to interact directly with your computer through your operating system. Most operating systems offer a terminal interface underneath the nice graphical interface that you're used to using. And this is that black screen with green text kind of interface that you see in a lot of Hollywood movies. Well, that's not made up. That's actually a real way that you can interact with your computer. It's often called a command window or a command line interface, CLI, or a terminal. They're all the same thing, and they're just a way to submit commands directly to the operating system. I've got my Macintosh up here, and Macintosh does ship with a terminal application built right in. I think it's actually just called Terminal under here, Utilities. Yep, there it is. But I've gone ahead and downloaded a free alternative called iTerm that I like a little bit better. And this is true on any operating system you're on. There's always a built-in terminal on Windows. It's called the command window. But there's a lot of free, more powerful alternatives out there that you can download if you so desire. It doesn't really matter which one you use. Whatever you're more comfortable with is fine for what we're doing in this series. You just simply need access to this terminal on your PC. Now, in order to determine that Python is in fact installed and see what version you have, a really simple command will do that. Just type Python space dash capital V. And there you can see it told me I have Python 2.7.2 installed. I can also, I think, use dash version. Yep, Python 2.7.2. So either one of those commands is going to tell me that, yep, I've got Python installed. Here's the version I have. I know that it is installed properly. If you get back something like unknown command or command not recognized, that means you don't have Python properly installed. You need to take a step back and figure out what you might be missing. Google, a lot of times, will be your friend there. Now, if we're ready to write some actual Python commands, we want to get into interactive mode. That's actually really easy to do. From the command line, we simply type Python. Hit enter, and now we are in the interactive mode. And you can tell that because of these handy little triple arrows down here. That's the prompt that tells us that we are in interactive mode and that the things we key in here are going to be immediately executed by the Python interpreter. So I can go ahead and show that off. If I come up here and I simply say print hello world, exclamation point. The very first program that you often write when you're learning how to program, the hello world application. I hit enter, and there, the message hello world came right back to me. Now notice that I put hello world inside of little single quotes. I could also do it in double quotes for Python. And we'll learn more about what that means later, but know that that's called a string literal. So we've passed in the command print to the Python interpreter, and we told it to print out the text hello world, and it did exactly that. So congratulations, we've written our first Python program. And yeah, I know it doesn't look like much. We haven't done anything really exciting, just printed a message on the screen. But you know what? Rome wasn't built in a day. The pyramids were built one brick at a time. Well, we're going to learn to program Python one little statement at a time. And trust me, before long we're going to be doing some really cool, powerful programs. Now, when you're running in interactive mode at the prompt here, Python does have a memory space that is retained between each of your statements. So you can create variables and assign them here. Oops. X equals Ben, and then you can later reference those variables. So print X, and now it's printing out Ben. And again, just a reference to the quotation marks. Notice that in this print statement I did not include the quotation marks, because if I had, of course it would have printed the letter X, not the value of X. So string literals versus variables, that's coming up in our next nugget, but just a little preview. Now, this is great for running quick commands or assigning things that we want to do, testing out things, that kind of thing. But for the most part, we're going to want to actually build longer, more complex programs and then execute them all together at once. The more traditional method of running Python that we talked about, normal mode. So let's go ahead and see how that works. So for this exercise, we're going to want to build a text file, and once again you can use any text editor you want. Notepad that's built into Windows, TextEdit that's built into Macintosh. I'm going to go ahead and use a text editor. It's a favorite of mine called Sublime. Get that launched up here. And I'm going to paste a quick Python program into this page. This is just some code I grabbed from the Python wiki. It's a bit of sample code, and it's just a game that allows me to guess a random number that Python is thinking of. If I come down here and drop out of my Python command, quit, open, close parenthesis, I'm going to move into my documents folder where I saved that file, and I'm just going to type python space sample.py, which is what I named it. So all that's going to do is run Python and tell it to execute the sample.py file, which is the file I just built. Go ahead and click enter. First thing it does, it asks for my name. Well, my name is Ben. Hit enter, and it says it's thinking of a number between 1 and 20. I think it's 10. I got it on the first try. That's excellent. That's on record, by the way. So, there you have it. All we had to do was build a quick little file and save it, and then we could execute it with the Python command. So now our second Python program has been written and executed. I hope you're excited. Okay, that concludes this nugget on the basics of Python. We talked a little bit about programming itself. We took an introductory look at the concept and the idea of programming computers to get them to do what we want them to do. We talked about how computers are logically malleable, but we as developers need to be able to provide very explicit instructions to those computers so that they can perform exactly the way we want them to perform with all of the ambiguity that natural human languages introduce. Then we took a look at why Python specifically. What makes Python such a great language to learn, its popularity and its platform independence, and why you and I want to add Python to our resumes. Lastly, we got down into the code and we actually executed some Python programs. We wrote our first Python Hello World program, which was just one line, print hello world. And we took a look at a small little game that had been programmed in Python, and we saw how to execute that in what's called normal mode. I hope this has been informative for you, and I'd like to thank you for viewing.